Hashtag the physical AI stack. Yesterday we looked at the moment when intelligence gets a body. Today the question becomes more technical. What is that body actually made of? Because a robot is not one model. A robot is a stack. And if one layer breaks, the whole miracle becomes a demo. That is the important distinction. The future of physical AI will not be decided only by who has the smartest model. It will be decided by who can connect perception, simulation, reasoning, compute, motors, energy and feedback into one reliable loop. Hashtag a robot is not ChatGPT with arms. The first mistake is to imagine a humanoid robot as a chatbot placed inside a metal body. That picture is emotionally powerful. But technically it is wrong. A language model can answer late. A robot cannot always move late. A language model can be corrected after the answer. A robot may already have dropped the package. A model can produce a beautiful plan. The floor may disagree. This is why the physical AI stack matters. It forces intelligence to pass through reality. Not only words. Weight. Friction. Torque. Latency. Heat. Battery. Grip. Balance. Human unpredictability. In digital AI, the model is often the product. In physical AI, the model is only one layer inside the machine. Hashtag layer 1, perception. Before a robot can act, it must see. But seeing is not the same as understanding. Cameras are not enough. Depth sensors are not enough. LiDAR is not enough. Tactile sensors are not enough. Force sensors are not enough. The robot needs a living picture of the environment. Where is the object? How heavy might it be? Is it rigid or deformable? Is the label facing the scanner? Is the human walking into the path? Did the box move since the last frame? Figures Helix logistics work shows why this layer matters. Package handling is not a clean lab task. Boxes, bags, labels, moving conveyors, changing shapes and imperfect grasps all create a messy physical problem. Figure described improvements like stereo vision, multi-scale visual representation and learned visual proprioception because the robot must not only recognize objects. It must understand its own body in relation to those objects. That is the difference between computer vision and physical perception. Computer vision says, I see a package. Physical perception says, I can reach it, orient it, correct the grip and avoid losing it. Hashtag layer 2, world model and simulation. The second layer is the world model. A robot needs some idea of what may happen next. If I push this object, will it slide? If I grab this bag, will it deform? If I step here, will the floor support me? If the human moves left, which path is safe? This is why simulation is becoming one of the most important layers of physical AI. You cannot train robots only by breaking real objects. It is too slow. Too expensive. Too dangerous. NVIDIA is attacking this layer directly with Cosmos World Models, Isaac Lab Arena, and OSMO workflows. The point is not simply to generate impressive robot videos. The deeper goal is to create synthetic data, evaluate policies and simulation, orchestrate training pipelines and reduce the gap between research and deployment. The robot needs a rehearsal space before it enters reality. But this also creates the central problem. Simulation is not the world. The lighting is different. The friction is different. The object bends differently. The human does something nobody modeled. So the real question is not, can the robot succeed in simulation? The real question is, how much of that success survives contact with the real world? Hashtag layer 3, reasoning and action. This is where models like Gemini Robotics, GR00T, and Helix become important. Google DeepMind describes Gemini Robotics as a model family for physical agents, systems that can perceive, reason, use tools and interact with the world. Gemini Robotics 1.5 is a vision language action model. Gemini Robotics ER 1.6 is focused on embodied reasoning, planning complex tasks and making logical decisions about the physical world. NVIDIA's GR00TN 1.6 is also a vision language action model built for humanoids. Figure describes Helix as a VLA model that unifies perception, language understanding, and learned control. Different companies. Same direction. The output of AI is no longer only text. The output becomes action. But action is more demanding than language. If the model says, "Pick up the red box," the robot must transform that sentence into a trajectory. Shoulder. Elbow. Wrist. Fingers. Force. Speed. Correction. Stop condition. Recovery plan. This is why a physical AI model must think in more than language. It must think through motion. ## Layer 4, Edge Compute. A robot cannot send every decision to a distant cloud. Some decisions can wait. Others cannot. A robot arm moving near a human hand needs low latency. A drone avoiding an obstacle needs local reaction. A warehouse robot correcting a failed grip cannot wait for a long cloud round trip. This is why edge compute becomes part of the physical AI stack. NVIDIA's 2026 robotics announcement points directly at this: Jetson Thor for humanoids, Jetson T4000 for energy-constrained autonomy, IGX Thor for industrial edge systems. The message is clear. Physical AI needs intelligence close to the body. Cloud AI can train. Cloud AI can simulate. Cloud AI can coordinate fleets. But the body needs local compute for perception, control, safety and fast correction. If the brain is too far from the hand becomes dangerous. ## Layer 5, Actuators, Hands, and Batteries. This is the layer where hype often dies. A robot demo can look intelligent for 30 seconds. Real work is different. Can it repeat the motion 10,000 times? Can the wrist survive? Can the motor stay cool? Can the hand grip fragile objects and heavy objects? Can it run long enough to justify its cost? Can it carry real payload? Can it recover after a slip? Scientific reports recently summarized why construction humanoids remain difficult. Dynamic sites demand perception, dexterity, robust locomotion, payload capacity, battery life, and human-robot collaboration. The same paper notes that battery endurance and energy efficiency remain critical bottlenecks. Continuous locomotion, balance correction, and high-torque actuation consume power fast. This is the part people forget. AI can improve quickly in software. Motors, batteries, gears, sensors, heat and materials improve more slowly. The robot is where Moore's law meets gravity. ## Layer 6, Feedback and Recovery. The final layer is feedback. A useful robot is not the one that never fails. That robot does not exist. A useful robot is the one that knows what to do when the plan breaks. The object slips. The package arrives rotated. The person interrupts. The floor is wet. The battery is low. The motor overheats. The sensor is blocked. The task changes. Now what? This is where physical AI becomes more like a living operational system than a single model. It needs monitoring. Logs. Fallback policies. Remote assistance. Human override. Fleet learning. Maintenance signals. Incident review. In a chatbot, a bad answer is a bug. In physical AI, a bad action is an event. Events need recovery architecture. ## Why demos are misleading. A demo asks, "Can the robot do this once?" A product asks, "Can the robot do this every day?" In different lighting. With different objects. With tired motors. With low battery. With humans nearby. With messy data. With edge cases. With liability. This is why physical AI moves slower than software hype. Not because the models are weak. Because the world is strong. Reality pushes back. And every layer of the stack must absorb that pressure. ## the main conclusion. The next phase of robotics will not be won by the best demo. It will be won by the best stack. Perception. World models. Simulation. Reasoning. Edge compute. Actuation. Energy. Feedback. Safety. Recovery. That is the physical AI stack. The robot is not one model. It is an agreement between software and matter. And the companies that learn to connect all layers may become the infrastructure builders of the next AI era. Because the real question is no longer, can AI talk about the world? The real question is, can AI move through the world without making it worse?